Welcome to my channel. Today I want to cover primarily how to calculate the umbra, the shadow the Earth casts, and what the moon, later on we'll talk about how the moon passes through that shadow to create a full lunar eclipse. The moon also has an umbra, and we'll talk about that in another video. First of all, I want to start off with giving some more refined numbers for some of the things that we've been calculating in the earlier videos. The radius of the sun is 432,288 miles, or 695,700 kilometers. The radius of the Earth, 3,959 miles, or 6,371 kilometers. I've been using 4,000, which you can see is fairly close for the kinds of numbers we're talking about. That's easily within an error margin that's pretty small. And finally, for 1 AU, I have the 92,955,807 miles, and I've been using mostly 93 million, so you can see that's definitely within 1%. And you can also see that it's 149,597,870,700 meters. That's how far the mean distance is from the Earth to the sun. So I wanted to get those corrections in there, or those refinements, so you'll have those for reference. In addition, I had a cousin of mine say that he felt that maybe my lectures were going to go over the tops of the heads of some people who might find trigonometry a little difficult. And I just wanted to point out that primarily I've been trying to use just the tangent function, and I've explained how it works. I may go into a little more detail in another video at some point, but it's basically a ratio. It's very simple. It's not highly complicated at all. They have established that a particular angle will always have a certain ratio for a right triangle of the opposite and the adjacent side. It's also true for the hypotenuse, the opposite, hypotenuse and the adjacent, and so forth. They work them all out. And there are tables for all of those, and your calculator has these in them. It's a very straightforward thing to do, so I hope you aren't put off by the calculations we've been doing, because they do allow you, with your own two eyes, your own brain, and your own evaluation, to calculate things that are obviously true, which will help you to deal with people who will lie to you. This is happening all the time. The flat earth channels will make stuff up. It's basically a religion, and so they're going to stand fast to what they believe no matter what kind of evidence is put forward. I'm not really talking to those people, because those people are not open to listening. They're not open to reason. They don't care about reality. They care about their religion. Okay, I'm not talking to them. The people I'd like to reach are people who are coming across these flat earth channels and thinking that perhaps they're real, that they actually have the truth, a secret, and that there's some kind of vast conspiracy trying to convince you that the world is round and spherical, when in fact it's flat. And that's just wrong. It is not flat, and there's all kinds of proof that you personally can go out and run to ground and know clearly within your own heart that you have been lied to by the flat earthers and the world is spherical. Okay, today I'm going to proceed on to the calculation of the umbra, the shadow that the Earth casts. We'll start with the drawing to show the basic relationship. There's the sun on this side, the Earth over here, and this back here is going to be the shadow. And we're going to calculate the length of that shadow. Alright, this value here is going to be the radius of the sun. That value there. That's going to form a right triangle. We've been using those a lot because they're very helpful. But the top of the sun to the center of the sun will be the radius of the sun, and we're going to use that for this side here. And over here we're going to have the radius of the Earth. And this, of course, is going to be the umbra length, which we'll call LU. All right, so we have The distance between the sun and the earth we know, that's 1 AU. We know the radius of the sun and the radius of the earth, which we talked about already earlier. And so now it's just a question of figuring out how we're going to calculate this length, this LU over here. Well, as it turns out, you can see that they're both these triangles, the one using RS as one side and the one using RE for one side, they both have the same angle over here. Therefore, we know that the ratio between these opposite sides and the lengths, which are the adjacent sides for these two triangles, they're going to be the same. So knowing that the ratios are the same, we can then set up, using the tangent function, an equation that will allow us to create a single equation with a single variable. And we'll be able to use algebra to solve that, to find out exactly how long LU is. So we start with this. The tangent of this angle is going to equal the RS, the radius of the sun, divided by this entire side, which the length of it is 1 AU plus the value of LU. The tangent of that angle will also equal the ratio of RE as the opposite side and LU as the adjacent side. So these two ratios are going to be equal. They have the tangent function tells us this. We can therefore just drop out this tangent part and just use these two as an equation to solve. And we know what RS is, RE is, we know what 1 AU is. The only variable is LU. So we have one variable, one equation. We can solve for that using algebra. The first step is going to be to multiply both sides by LU, which will get LU on the top over here, and multiply both sides by RE, which will get RE on the top over there, and then we'll do the same thing with the bottom, so we effectively flip this over, but they're still equal, and we can work from there. Algebra will allow us to split this term up into these two separate terms, which will allow us to manipulate them using addition and subtraction rather than just trying to multiply through. I'm going to move up to the top here where I have some more space. So I erased the little diagram. We still have the triangle here so we can see what we're doing. Okay, up here at the top we have our umbra length divided by the radius of Earth minus the umbra length divided by the radius of the Sun. And that's going to equal 1 AU divided by the radius of the sun. The next step is we're going to multiply through by RE, and that leaves LU, the length of the umbra, alone, and it adds the RE up here. So RE times LU over RS equals 1 AU times RE. So we multiplied both sides by RE, which is allowable in algebra. And we come up here and we multiply through again, this time by RS. We want to get rid of all these denominators. So now we have LU times RS, which is that term there, minus RE times LU, which is this term here. That's going to equal 1 AU times RE, which is this term here. So now we've gotten rid of the denominators, and we're going to move on to solving for the LU. First of all, we'll pull LU out of this term here, these two terms, and use the distributive property to use LU times RS minus RE, and we left the other term alone. Okay, now we're going to divide both sides by RS minus RE to leave LU by itself. Now we can finally solve for LU. That is going to equal 1 AU times RE, which was already there, divided by the RS minus RE term. Now we move down here, and we can actually start filling in values to solve for LU. The Value of 1 AU is 92,955,807, and we're going to multiply that times the radius of the Earth, which is 3,959 miles, and then we're going to divide that by the radius of the Sun, which is 432,288 miles, minus the radius of the Earth, which is 3,959 miles. Multiplying that out, we end up with 368,012,039,913, and we're dividing that by 428,329. That's what these all factored out to. When you do that, punch that in your calculator, you come up with 859,180.8 miles. So the length of an Umbra behind the Earth is going to be that distance. So we have calculated the Umbra of the Earth. We'll use this later on when we're discussing the lunar eclipse and why this is important. Also, at that point, we can discuss the width of the lunar, or the Umbra, at the point where the moon crosses over. It actually loses about 25% of its width by the time when you go as far away as the moon is. So it's not exactly the 8,000 miles across for the full shadow. It's actually going to be a little bit less than that, but it's close. Anyway, we'll discuss that more in the lunar eclipse area. If you liked the video, please click like, and if you haven't subscribed yet, please do. And I'll see you next time.